Let's start. So here's the agenda. First of all, I will give a short introduction to the tutorial, outlining the overview what OpenMTC is, the history and the transition to open source. Then my colleague Ronald will show you how to build your own setup and get started. Then afterwards we will work or show you how to work with the API and the SDK. By the end we will show you the simulation of the virtual sensors we have created, that you have an end-to-end scenario from the creation of sensor data and the virtualization or visualization of the sensors in a dashboard. So what is the OpenMTC platform about? It's an M2M IoT middleware which we developed here at Fraunhofer FOKUS, and it's based on the 1M2M standard. And the 1M2M standard is an international standard and specifies an horizontal approach of an M2M platform. And as you can see, the platform consists of a backend and gateways, and these gateways are usually located close to the sources where the data are generated. And for each of these applications domains, you would require specific protocol adapters, as they have specific requirements. And this platform is able to aggregate the data, collect the data, and forward it to applications. And these applications can initiate event-driven actions. And most importantly, the platform is independent of the underlying hardware and networking infrastructure. The platform is implemented in Python and will be or is released now under the Eclipse public license version 1. If you take a bit closer look at the architecture, you see here, as I mentioned, on the southbound, the protocol adapters that are technology specific. We have an application framework. We have the gateway and the backend part. The gateways are responsible for sending and retrieving the sensor data. And of course, there are also some services running locally, which is the caching of the sensor data and the device management, and also the authentication. And the backend is aggregating multiple gateways and providing a unified 1M2M compliant API towards the application. And we also have an SDK which allows you to easily develop applications. Coming to the history of OpenMTC, as already mentioned, we started in 2011 with developing the platform. The software was used or is still used in multiple national and international projects. We also had various deployments on commercial customers where we provided our OpenMTC platform and deployed these on premises of our customers. Today it's my pleasure that we can announce this platform and releases as open source, and we hopefully, or it's up to the community to contribute to this platform in order to continue the success of platform. And this was from my side with a short overview of the platform itself, and I will now hand over to my colleague Ronald Steinke, who will guide you through the technical details. Thank you.
Hey, thank you, Thomas. So let's have a quick look to the agenda again. So first we will cover the getting started, which means check out repository, build of some Docker images and a simple setup deployment. Then we will see a hands-on where we discuss about the API usage and also development of basic applications. And in the end, we will showcase some sensors, some simulated sensors and dashboard where you can see this sensor informations. And afterwards, we will have the questions and answers section. So for this, as we have here now a Windows machine, and as Thomas already said, we have a Python implementation, but we are based on Linux or Mac OS. I will switch to a virtual environment. Okay, and so where we will start at the website, where we have a lot of documentation and also a link to GitHub. And the first step was that we want to check out the repository. And on GitHub, where you can find the repository, they also have the link to clone the repository. Just a quick repair. So to clone this repository, as you know, on GitHub, you need to have git installed, and we will just do the git clone. Okay, this takes some time. Then we will go into the repository, and as you can see, it has downloaded a bunch of files, which we will discuss not in detail. And for getting started, we have already cloned our repository, and now we want to try to build a Docker image. For this, there is also a guide for installation Docker on different systems. So this, you have to make sure that this one is working. For example, what you can test is simple, something like Docker images. So I have already built them, but we will repeat this, and otherwise there would be an error. And now we try to create the gateway. The gateway is one of the CSEs that we have inside. So we have a gateway and a backend. And if we build the gateway, that takes some time, especially when you run it the first time, because it will build some, or will download some base container that is based on Debian, and then we'll install a lot of packets that are shared by all the other applications. And so this takes some time, but as that's the advantage of Docker, so it will use these already existing containers and then add some more layers where it will just install the other thing. So what we see here is that it will install some Python modules that were installed by pip, and in the end you can see, so we have now running, there were no errors, so we have the gateway built, and we repeat it as well for the backend. Okay, when this is done, we will check that both images are built, and we will run one of these images. So we see that the backend and the gateway were built. Some information about how this script is working you can find in the documentation. And for the next step, we will just start a gateway. And afterwards, we will see if we can reach it. So simply docker run. Name gateway is just for addressing it with Docker commands. We will publish the port to the host machine. This means that we can use the Docker container from the host. And here we are publishing the port 8000 because initially configured as the gateway that it can be reached under the port 8000. Oh, sorry, I forgot to daemonize, so we want to so I call it gateway 1. And now we try to reach it under the port 8000. The base path of the CSE base resource. So this is some terminology from the 1M2M standard, but for this, other documentation is needed. I will not go into detail into this. And we see that we get some response. I will just introduce for the rest of the webinar tool that I will use, so curl for all my HTTP connections, and I will use JQ for JSON processing so that it's pretty printed. So what we are seeing here is the payload is in JSON and it will use short names, but I will not go over all of them, just some to tell you. So we have here the CB, which is the CSE base, it's the type of the resource. We have here children, but there is nothing more than just the CSE base, which is the root of the CSE. We have an identifier, which is MNCSE1, because it's the gateway. And we have some empty labels, some last modified time, the creation time, and the point of access where it is reachable. So, and as we have now seen an API command to retrieve the CSE base, we will now go on as we had it here with the hands-on part. So what we are going to do now is we want to create an application entity. This is another resource in a 1M2M, and every app that is using the CSE needs to register, and registering means here create an AE application. So all the functions that are done with OpenMTC and 1M2M are CRUD based with resources, and so we can create, retrieve, update, and delete several kinds of resources, and all of them are functions. So first we are creating this AE, which is symbolizing an application entity. So I can now try to copy this command completely. So, but maybe here we will not say example app name, but let's say it's webinar AE. The API here is placeholders just for an application ID. It's to identify several AEs that they belong to a specific application. And RR means here request reachabilities. These attributes we have to provide because it's defined by the standard that it is mandatory. So in the end, we have returned the application entity that was created. So when we check, for example, the creation time, so it was 15:30 UTC, so that was fine. Next step is we want to provide some content which we want to retrieve later, and for this we need to create a container. In 1M2M we have the container that contain other entities that are the content. And so first we have to create a container. So the same thing I can do here is just copy from the website. And as well as we have changed the name, we also have to adapt it here because we want to create it under the root of the before created application, and we just call it also webinar CNT. As I said, I want to use JQ for the rest of the tutorial. to see. So we have created a container which is called webinar container. It has a resource ID, CNT0, and it also has a parent ID which was CAE0, the before created AE. So now that we have a container, we can create some plain text contents. So in 1M2M we have the resource type, which is the content instance. So the short name is SYN, and within there are two major attributes. One is the content, it's the content itself, and then we have another thing which is the content format. And this is on the first side, on the one hand, just plain MIME type, and then with a colon, a number from 0, 1, or 2. 0 means that it's just plain, and 1 and 2 means that it's base64 encoded. So as before, we just copy the example. We paste it in as before. We have to adapt the names. So it was under webinar AE and webinar container. And for example, we just say here webinar. So you see we have created a content instance with a content webinar just in plain text. To retrieve now the content that we have created, we will check the container itself first. Sorry. And here we see now that we have a child type, which name is content instance something. So it was just a created name because this time we have now provided a name for this. So we'll just copy this one and we'll append it to the end. And we see now that we have here our result, and here we can use, because I will use it afterwards, use JQ to just get the content of it. But as checking the name of the created content instance is maybe not the best, there is in the container itself always an attribute which is called virtual, or it's then the virtual resource, which will always point to the latest content instance. And then we have the same with webinar. So as we have created now a plain text, we can also just add, let's say we want to provide some application JSON and want to base encoded base64. We will use some some trick to just say, okay, we want to create foobar as a JSON, and this will be base64 encoded and inserted in the content type. So what I've done here is just echoing the foobar JSON itself, encoded with base64 minus WO means that the lines will not be broken, so it means it is continuously, and then we will just add it to the container. So now we have created it, and as we will check now the content latest, we see that it's the base64 encoded version. So what we can do now is just decode it, and we see it's the foobar content that we had already. So now we want to go to the development of a basic application, because doing curl examples with just create content and retrieving it is maybe a bit, it takes too much time. So we have provided, as Thomas said before, an SDK which you can use to create your own application, and it will take a lot of the work from you and provide you with functions like create application, create container, push content, and so on. And for this, we have provided some training applications, and these can be run from the console, and you can also have a look into it. Here we have an explanation of what are the different applications, and then I will just look into one of it. And it is also, you have these trainings app in different steps so that you can see, okay, first I start with a very basic example, and then I will extend it and so on. And I will just have a look into one IPE. IPE means interworking proxy application entity. It's an application that deals with physical, or can deal with physical sensors and actuators. And it will just map, for example, the sensor values into the system so that it can be used by other applications, or it will provide some containers where other applications can send some commands that will be interpreted by the interworking proxy and will translate it back to the specific device. So when you start with an application, you have to import. So here is Python. I will not go into detail how this is working exactly. So you have to import from OpenMTC app 1M2M the XAE. So it's AE for application entity, but it could be that it's just any of this. So what we have here is just a remove registration equals true. So when you start the application, it will register, and when you shut down it, for example, with Control-C or anything else, it will also deregister. So that when you start it more often, otherwise there will be a conflict that this application is already running. Then we have a function that is on register. This will be called just after the application has done the registration, so you don't have to take care. And then you can, for example, start running with your application logic, create more containers, subscribe to already existing, discover other containers, and so on. And here in this example, this is the class, and in the back, if this file is called as main, then we will import a runner. A runner supports that this application can be run as a standalone thing, so it will not just stop when it has done its operation. We will define the host. For example, here we have localhost 8000, which is the POA of the gateway that we have started before, and then we will just create the app and say runner app run host. But you can always have a look into it and try it out step by step. So the next step, we have just added to, we see here, adds creation of a container for devices. So as we want to have here an IPE, we create a container which is called devices. We introduce a function for random sensor data generation and introducing an endless loop. So what we see, we create a container, and this container is imported from OpenMTC 1M2M model container. And here we just add the resource name equals label, and this is from the 1M2M standard, just camel case. So you can just copy it from there. And you can take this model when you want to create something, and also when you retrieve it, it will automatically parse it into this model file. And then we see on the next, we are storing the link or the returned container, which is at self-create container. None means here, but you will have an SDK documentation as well, which is discussing it in detail. It's the target, and when you put none, then it is the application itself. Then the container that we have created, we can add some labels and also max number of instances. Max number of instances is here for limiting the creatable content instances, and here we just want to say no content instance at all is allowed. We're just using it as in a container that we want to create other containers. And labels, for this we will see later when we showcase some example. We are using the labels to discover later other entities. And here we have get random data, which is by default doing nothing, and the run forever that will make sure that your app is not starting. So in the next step, we will add some random generation. So for example, that you see, we are just using a Python function, which will give a number from 0 to 1, and we will just multiply it with something so that when we want to emulate a sensor, that it always pushes other data. In step 4, we are creating 4 sensors, temp 1 and 2 and humidity 1 and 2. We are defining some thresholds, a value range, a value offset. It's just for the randomization of the function. And then whenever get random data is called, it will just try to say which sensor is now pushing data and what is the value of it. But it will not do anything at all. So now we are coming to the more important thing. So here, when get random data is called, so as I said, there's a random number generated, and out of that it will generate the rest. So first it will check of the threshold, so not every time it will do this. Then it will collect a sensor out of these 4 that we said before. If it is a temperature sensor, then it will generate some temperature data. Otherwise, it will generate humidity data. Then this value is is generated, and it will call the handled sensor data. And this handled sensor data is now checking if the sensor is not already recognized. Otherwise, it will create a sensor structure which will create another container and then pushing the sensor data into it. So this means we have now a generation of just some random data for a random sensor, and we have created before the devices sensor, and when we have a new sensor, we create a container for this as well, and then push just the data. And in the end, we have a complete example at version 7. Where you see we created just from the beginning and enlarged it, so on and so forth. And this application you can just start from it was here. So here I want to use now this the sensor and the GUI. The GUI is doing something different from the IPE. So the IPE is pushing its data to the gateway. The gateway will be then registered to the backend, and the GUI is registering to the backend. And the GUI is just looking for some data, will find it, and then subscribe to it and also print it. So first I will start the Docker container as we had it before. I've already prepared the containers for starting. So here we have now a little bit extended example. We have Docker run -d the backend, which is listening default at port 18,000. We will enable the notification. This is used by the GUI and use it with the backend image. So this one is started now. Then we will start a gateway as well. Here we use the Docker linking technique. So we've created before a backend container with the name backend, and we will link it to backend. Here we will open port 8000, enable the notification, enable the registration that it will register to the backend, and here we are using the backend name, which is Docker specific, to connect to it. And now we will create the gateway. So we have now 2 Docker containers running. One is the backend, one is the gateway, and we can check it again. So here we see we have the gateway created and it's reachable at port 8000 with the ID MNCSE1, and there's already now one child, which is the remote CSE, which is representing the backend, which is called INCSE1. So this means, there is the registration successful, and the same is for the backend, which is reachable at 18,000. It has also a child which is called MNCSE, so that the registration is a two-way thing. So what I want to do now is we're going back to the demo page where we say, okay, when I run doc training start app, there are already this existing different 4 applications, and it can start the final developed version of this one. Okay, and we are going to start now the IPE sensors final one. So you see it's initializing sensor and will push the data. And on the other side, we will just check again if you see now that there is a test IPE created. And now we have another example for an API usage. It's a discovery. It is just a retrieve or a get in HTTP, and in the end there is a query parameter FU, which is here in this case filter usage equals 1. And then we will receive a list of all resources that are now created inside of the CSE. To limit this, we have different possibilities. For example, we want to have the TY, which is a resource type. And here, for example, the resource type 3 are all containers that are existing. And then you see there's only containers that are under this test IPE that were created by the IPE. For example, if I would stop it, and it will be killed when I'm doing this now, the resource set is empty. Another thing that we can do is we can look for labels, and as you saw before in the app development, we have added some labels to the containers. And so here I can limit it to only these containers that have this specific label on it, and so I can find out which containers are maybe relevant for my search. And just 1 second. So we want to see inside of this container, and then what we have learned, we want to have latest to see the content, and as it is base64 encoded, we are using just the same trick as before. So we see there's a type temperature, unit degrees Celsius, and value 22. And to finalize this, we will also start the GUI. start app, and we say 1M2M GUI sensors final, so with a 4. And this is now subscribing to its resources. Internally, you can look it up in the step-by-step. It will discover with the same label we had and will then subscribe to the specific container. And whenever there's new data pushed into this container, it will be forwarded to the GUI. And maybe here we can see again just the final version of this code, how this is working and how the SDK will ease the, oops. Just how it is receiving the data. So here we see in the beginning on register, it will just do a periodic discover with the labels measurements, as we also did it before. And whenever it finds a URI in this list, it will add a container subscription with the URI and just a function. And this function is called with the container path and the data. And it will also, so you don't have to do base64 encoding and so on. It will just done automatically. And in Python, when you have JSON, you have just the object and can work with it whatever you want to do. Okay, then we come now to the last point, showcasing. And here, just finish this. So here I prepared another session already because the dashboard is not yet part of the open source resource, but open source release, but we will add it soon. But what we already have is an FS20 IPE, which is also supporting a simulated mode. And I have already prepared the gateway, which is now running at another port. And just to show you quickly, there's already the CAL 868 IPE that can work with specific devices, but you will find it in the documentation, and it will already connect. And then you see there is a simulated mode that is enabled by default. That is true. If you disable it, then you can say there is a CAL device at this device. But here we will use the simulated mode. And we will just start it. And it will just start creating temperature and humidity values. And we can, sorry, the wrong port number. So we have here two containers that are interesting, the switch we ignore. And for example, we have a look to the so it's already pushing simulated data, but now we want to start the dashboard. This will take some time, but we will optimize it so that you can just reuse it as the other IPEs. And when it is started, then we can just have a quick look to the dashboard and how we are using the temperature and humidity data.
Okay, as Ronald already mentioned, the dashboard currently is not part of the open source repository, but as soon it's mature enough and usable, we will add it to the repository, and we hopefully will have it done by the end of the year.
And so then you can just use an already, besides of this training applications that are really simple with just pushing random data and just subscribing it and printing it on the console, you have an IPE where you can buy already existing physical devices, use it, and the dashboard where you can graphically see the data of it. So I think we are finished in a few seconds. Okay. So here I have already prepared okay, I have already, because we have not too much time, maybe I can try. Okay, I have already created a dashboard where I subscribe to the temperature data and to the humidity data, and you see the graph. But as I said, it's just simulated data, so the data is maybe not useful in the moment. But if you have real devices connected, then you can just see here. And what you can do with it, you can edit, for example, just change it how you like.
Here it's a widget-based approach that you can drag and drop and arrange it however you like it. Then you also will be able to store the dashboard configuration, and of course we will also provide additional capabilities that you not only have line charts, that you can also have different kinds of visualization from your data. And also I think there will be a discovery mode where you maybe
I'm showing because I removed the humidity chart now and re-edit. So as you see, the dashboard which is connected will see the gateway where the sensors were found is MNCSE1, and the dashboard is looking for such devices and containers on the labels that are also used in the FS20 IPE, on the CAL IPE, where you can see, but you can also change it. And for example, I want to add here a new widget, and I call it again humidity description webinar test, and then I just can reload it, but it has already found the temperature and the humidity sensor, and I grab this one, put it here. Say for example it shall have the haze 2 and the width of 4, and here we see there are planned more, but now we only use the line chart. We just say create and done, and then it's starting on. And so if we would have add more sensors, they can just add them, store them in different dashboards. For example, if you want to have another dashboard, then you can also have for different situations different dashboards.
Okay, thank you very much, Ronald. So now it's the time for the audience here locally and also remotely to ask some questions. So it was a really technical tutorial right now, but I would leave the floor to the audience in order to ask some questions. Do we have some questions here from the audience at the IoT forum?
Yeah, so what we have right now is that you can use HTTPS as a port. You see, before I have used only HTTP, but you can have it HTTPS, and then you can use certificate-based. And in the documentation, you will also find a chapter about this, how to use it, what you have to do, and what is it about. Also, because when I create this application, normally the application is also an identifier that needs to be used, but in the configuration you can turn it off, especially for developing when you don't want to deal with problems of authentication and authorization. But we have this, and also there's another resource in OneM2M that's called the access control policy, where you can granularly control the access to specific resources per application ID or CSE ID. But this would be too much, and so, but you will find it in the documentation. No, it's the API is simply so it's an implementation of the OneM2M standard, and they only have defined this specific API, which can be mapped to HTTP, MQTT, and CoAP. So we also have a CoAP implementation, but this is the only thing that you can do. So create create, retrieve, update, delete specific resources. On all these resources have a specific function. For example, when you have create a subscription, this will trigger notification. This is something like a function, but this is the only way how you can communicate with this these entities. This is more because so it's not only the containers that can be monitored, because containers are also only resources. So it's more that the application is using the CSE too much, and the CSE itself needs to be monitored. But this we don't have at all. So it's just simply the providing the functionality of this. But this can be just monitored by any other program you have, because you have just a process and say it should be limited like this. This is maybe more because here with OpenMTC, which is only the implementation, it's just providing the functionality of it. And as I said, the applications itself that can be developed with the SDK, these are bringing the services. And we only added this on the one hand, this IPE for FS20 that can already deal with some devices and dashboard. But anything else would be then just by developers who are using it. We have also
other tools.
yes.
Okay. And these applications that Ronald had mentioned, which bring then the added value, can run as on the gateway level as well on the backend side. Yeah. So you can also have some pre-processing applications on the gateway in order to make decisions if certain thresholds of sensor values are reached, that you can trigger already also actions. Also, and in this webinar, it was not the time to also to show how to actuate things based on events, but this can, of course, as done as well with the framework.
Because there you can just subscribe and then, for example, in Python check just if the value is bigger than this or that, and push content to somewhere else. So that's quite easy to implement this.
And it's also what you can see at one of the booths where we have the condition monitoring demo, where a certain temperature is reached, and then we start the engine, because not overheating the engine.
Yeah, so the OneM2M standard provided in the release 1 HTTP, MQTT, and CoAP, and we have now HTTP and HTTPS as well as MQTT, and we will try to add CoAP and CoAP secure and also MQTT secure somewhere in the future. And additionally, there's now also WebSocket since release 2 in OneM2M, which we probably also try to work on because there, or maybe just some background, because for subscription notification reception, there are different ways. When you want to have a notification, then you have to be either server capable, so you have to know your IP, and so that you are reachable from the CSE, or you implement this notification channel where you have long polling. But with MQTT, for example, where you're using the TCP connection and WebSocket, you can reuse the same connection, and so that's quite interesting, especially for devices that have tricky connections. And so this would be quite good. And they have a mapping how to deal with it, so there's no problem when an application maybe communicates with one CSE over WebSocket, then the CSE to another with CoAP and the other with MQTT, so that's no problem. So you can mix them all. Now OPCOA is kind of like a different standard, and there are some discussions, especially in the industry 4.0 community, which is maybe in which scenario you can use what. And there were now, so what we have seen in the last time, that there are not competitors. Maybe one is better used in this scenario and the other in this, and maybe to combine. And there are also discussions in the OneM2M community to see how this can be somehow integrated, or one of them is using the terminology interworking. So they have said, okay, we have a standard, but it's maybe not possible that everybody else is using it. So we have to see from the beginning how we can interwork with already existing things, and they are now looking for this interworking with OPCUA.
Yeah, but I wonder that there's a discussion within Industry 4.0, because when talking about going southbound in a manufacturing environment, then I think OPCUA is the standard.
Yeah, but this is the
sensors on the machine level. No?
Yeah, this is true. So there are a lot of manufacturers that, and also that are already in this domain. Let's say OPCUA is quite this, but there were also some people that have looked into it. Why not using 1M2M? So because that's maybe not to discuss this here in the webinar.
So, but when we are speaking about interworking, so what we have implemented is a protocol adapter that represents an OPCUA client and is able to talk to an OPCUA server in order to retrieve the data. This you can also see at the condition monitoring booth. And also we have a protocol adapter that is able to expose the data from the OpenMTC to the Fiverr context broker. So we are aware that there are other frameworks, and we try also to interwork with the existing one, and this is what we're doing, but not all of these features are part of the open source core, because we also need to monetize our the effort that we have put into the platform. And we also have on the website the service tab where you will find information about what services we will provide around this framework.
You mean specific for the open source version?
Yeah.
Or in general? So because we have this the bigger thing, and for the open source version we try that we the things that we need in other projects and also in the things we want to sell, that we will put some things that we need then also in the open source version, so that this can be so what we are using there.
But maybe we have 3 full-time developers that not only contributing to the open source code, because it's used also in different projects where we have to implement some specific extensions that are to the project. Some of them going to the open source base and some not. So this is how we work it. But also we have close cooperation with the Technical University Berlin. So there are also student projects that can work on it. Also, as we have licensed it under the EPL, there are of course contributions from third parties possible. Okay, there was another question. This is written on the website, and let's say all the Industry 4.0 related protocol adapters are not part of the open source release, and this we license as add-ons to the framework. But I don't want to go into the detail right now. Okay, I think we are close to the top of the hour. I would like to thank you all for attending. So we are really excited to see what's happening after the open source release, and we are happy to discuss with you face to face in the networking session. And yeah, thanks again for attending.